we are interested in finding the magnetic field at a distance s from this wire. So if I put this point here, so that S is where we want to find. So from introphysics to, if this is infinitely long, what's the magnetic field? B is going to be mu naught I over 2 pi S, and it forms a concentric circle, so this is going to be along the p direction. So that's the magnetic field. So let's find that using the Biot-Savart law. So all you have to do is just consider an infinitesimal length along the wire. So this, I will call this one is the L prime, and the position of that is what we call R prime. And we are interested in the magnetic field at this point P. So this is what we call R vector according to what we have here. So this R vector, this R prime vector, and this one is R minus R prime. Okay? So if I call this angle theta, then what's going to be the magnetic field? So the B field, B is going to be mu naught. Now, if mu naught over 4 pi. So how can I express I in terms of the magnitude of the current? I can write it as just the magnitude of the current I along which direction? Positive z direction, so I can write here I along z hat crossed with R minus R prime over the magnitude of R minus R prime. And here, what should I write for the L prime? You know, the current is along the z direction, along the z axis, so the L prime is just dz prime. All right? So what's going to be this vector, R minus R prime? So how can I write that? R minus R prime. Yeah, the magnitude, well, the magnitude, yes, but vector R, if I use spherical coordinates, vector R means this vector, right? So in spherical coordinates, how can I write it? It's just going to be S along what unit vector? S hat, right? I'm using cylindrical coordinate. Did I say spherical? Cylindrical coordinate. If I use cylindrical coordinate, this vector is going to be just the length S along S hat. All right? And R minus is C along the unit vector C. So minus of C hat. And this tells you that the magnitude of R minus R prime is just the root of S squared plus D squared. So B then becomes mu naught over 4 pi, the integral. So now I'm considering the finite length. So if this is L, so this is going to be minus L over 2, and this is going to be L plus L over 2. So I'm trying to find the magnetic field for a finite length F. So this is from minus L over 2 plus L over 2 of I Z hat crossed R minus R prime is that, which is S hat minus Z hat times by dz right over the magnitude of this cube. So that's going to be what? The magnitude of R minus R prime, that's going to be S squared plus Z prime squared raised to 3 over 2.
And that should be S hat minus Z prime Z hat.
Yes. Thank you. Anyway, this is going to disappear because Z hat crossed with Z hat is 0. So what we find is V is going to be mu naught I over 4 pi, the integral from minus L over 2 to plus L over 2 of Z crossed S hat. We get what? Yeah, S P Z. We are putting Z with S, that's equal to phi. So you have S P hat over this Z prime over S squared plus Z prime squared raised to 0. Yes?
I was going to say, if phi is coming from the x axis, right?
Yeah, phi is this angle.
So phi hat would be coming in that direction.
Phi is always tangential like that,
Right.
and that makes sense to you according to the second right hand rule. The direction of the B field is going to be along the H. Right? Yeah. So that is the magnetic field. So all you have to do is do this integration, and I'm going to skip that part. Okay. So you can look at is just transformation of variable. Well, actually, I used it in Cartesian coordinate here. So we use transformation of variable defined by tan of theta is what? S.
That'd be later.
Okay, theta. Well, okay, I think that's the difference. But if I use theta to be rather than that, if I define this one is theta, what's going to be tan of theta? Z prime over S. So, okay, use transformation of variable. And when it's infinitely long, what should be the limit of theta? From what one?
Pi over 2 negative pi.
Yes, from minus pi over 2 to pi over 2. So using the transformation of variable defined by tan of theta prime equals to Z prime over S, and which gives you Z prime is equals to S tan of theta prime. And if you use that, you can easily find this result. So what you would find is going to be B equals to mu naught I over 4 pi, well actually 2 pi times S sine of theta, where sine of theta naught is defined by what? It should be defined, it should be expressed in terms of S and N over 2. So if it is a finite length, you have to go from this to this, right? So when you reach here, if I call that one is theta naught, then you are going from minus theta naught to plus theta naught. So where theta naught is equals to tan inverse of L over 2 over S. So for infinitely long, for n tends to infinity, theta naught becomes pi over 2. All right, so this one, finding this force, you do that as an exercise. So there is one more example, magnetic force. All right, so. I don't know if I'm going to complete this. I'm almost totally, it's like 4 lectures, but I'm almost running out. So I think we may be able to.
And that's 4 lectures in chapter 5 or all the way through 6?
Okay, so chapter 5, yeah.
Okay. How many lectures do we have left?
Well, you know, just only one.